Hello everyone, my name is Allison. Today we are going to be discussing melting point and more specifically how to use a Mel Temp. Our learning goals for today include understanding what the term melting point means, being able to correctly operate a Mel Temp, and being able to analyze melting point results. As we progress through the video and into the pre-lab, be sure to keep these goals in mind. Please take a moment to pause the video and answer guided question 1 on the corresponding worksheet. Zurbrigg describes melting point, abbreviated MP, as the temperature at which the first crystal just starts to melt until the temperature at which the last crystal just disappears. If we look at the image on the right, we can see that you are actually taking two temperatures, thus making the melting point more of a range and less of a specific point. Melting point will most often be taken in the organic chemistry lab to determine purity. Prior to taking the melting point of your compound, you should know the expected pure melting point. Then, when you take the melting point of your compound, you will know if it is too wide, too far below, or too far above your expected value, meaning your compound is impure. Another reason you may take the melting point of a substance is for identification purposes. If asked to do so, you will be given a list of possibilities. To ensure it is the substance you have in mind, you can mix your synthesized solid with the pure substance and take the melting point. If the melting point of the mixed and unmixed is the same, you have succeeded in identification. Please take a moment to pause the video and answer guided question 2 on the corresponding worksheet. When taking the melting point of your solid, you will need a capillary tube, which should be available on the benches next to the Mel Temp, a spatula, your dried solid with its expected melting point, a watch glass, and the Mel Temp itself. Capillary tubes, also called melting point tubes or melting point capillaries, are thin tubes with one closed end and one open end. These are used to hold your sample in the Mel Temp. Prior to going into the Mel Temp, your solid should be completely dry. To ensure this, let your solid dry for as long as possible and spread into a thin layer on your drying plate at the end of lab, once your product has been synthesized. To load the solid into the capillary tube, place a small amount of solid onto your watch glass using your spatula. Then thrust the open end of the capillary tube into the middle of the pile of solid. Doing this traps the solid inside the tube. You want about 1 to 2 millimeters of solid. You can then carefully turn over the tube so that the closed end is now down. Tap the counter gently until all solid moves to the closed bottom end of the tube. Before we actually put our tube into the Mel Temp, we want to be comfortable with the equipment. This is what a Mel Temp looks like. It has an on-off switch, fuse for electrical protection, voltage control used to set the rate of heating, not the temperature itself. Here is the light source, which illuminates the sample, an eyepiece that magnifies the sample, the thermometer used for temperature readings, and the 3 slots allotted for placing your capillary tubes. Before you touch anything, be sure to examine the temperature. The Mel Temp itself can be hot, and we don't want anyone getting burned. We also check the temperature to ensure that it is below 20 degrees prior to adding our capillary tube. If not, you should wait. After checking the temperature, we can place our loaded tube into one of the 3 slots. Start with the voltage at 0, so there are no surprises. We can then turn on the Mel Temp, which should turn on both the heating mechanism and the light source. Now we can set the voltage control to any convenient setting. This is where knowing the melting point of your substance comes into play. If you have a substance with a higher expected melting point, you can place the voltage control to 4 or 5. If not, stick to 3 or lower. Once we are within 20 degrees of our expected melting point, we should turn the dial down and take it very slow. Somewhere around 3 is a good spot. Throughout this entire process, we should be looking through the eyepiece for signs of melting. When the first crystals start to melt, record the temperature. Then keep watching and record the temperature again when the last crystal just disappears. This will tell you your melting point. If these appear to be the same as the expected value, your substance is either extremely pure or you raise the temperature too quickly. When finished, turn off the Mel Temp, set the voltage control to 0 for the next person, and remove your tube to throw away. Please take a moment to pause the video and answer guided question 3 on the corresponding worksheet. As a reminder, our learning goals were to gain an understanding of what the term melting point means, being able to correctly operate a Mel Temp, and being able to analyze melting point results. Like always, please remember to reflect on what you just saw, discuss the content with peers, rewatch, or reach out with questions. Have a great rest of your day.